All right, so here we're at 7.5, calculus, AP calculus AB here. And we're talking about inverse trig functions. So just a quick video here. Inverse trig functions, you'll see here in the red we have the sine function, okay? So here it traditionally starts at 0, right? Goes to a maximum, back to 0, down to a minimum, and then one complete cycle ends at 2 pi, approximately 6.28 radians. So that's our sine graph. Now, obviously, this sine graph extends in both directions, and I want to focus on the middle part of this graph right here. If we're talking about inverse, what you want to remember is that inverse means reverse. So whenever we have a y equals sine x, the inverse graph would look like x equals sine y, okay? Now, this is really strange, I get it, but if you, computer is freaking out here. So look on this, these are notes from class here today, but y equals sine x would be the black graph, x equals sine y would be how you would express the inverse graph. Now if you didn't want x over here by itself, but you wanted to solve for y, that's when we write it like this. You would write it y equals sine to the negative 1 of x, and this is the inverse, okay? Now what does that look like on the graph? Well, if you look over here on the side here, and I have the inverse sign over here, I'm going to light that up in a second, but remember with any other inverse, what you want to do is you want to focus on the y equals x line, and that y equals x line is going to provide us with a mirror, okay? And so when we reverse x and y, we actually flip the entire function about that or around that y equals x line. So what we need to do first of all, in order to show the inverse as a function, I'm going to have to restrict the domain here. So I'm going to take this sine graph and I'm going to actually just show you where it's a one-to-one function, okay, where it doesn't double back on itself here. It's a one-to-one passing the horizontal line test. That means that the inverse will pass the vertical line test and be a function. So we're just going to focus on this section of the sine graph. Now here's what the inverse graph looks like in blue. It's a perfect reflection about the y equals x orange line. And so if I just isolate now this inverse function, this is what it looks like. That is y equals sine to the negative 1 of x. And notice that the domain and the range are both restricted, okay? So the domain is from negative 1 to positive 1, and the range here is from negative, that's pi over 2, to positive pi over 2. All right? So let me show that once more, okay? So here's the portion of the sine graph. Here's the whole sine graph. Here's the portion of the sine graph reflected about the y equals x line to give us this right here. All right. So that's what the inverse sine looks like under the restricted domain. And we are going to be working with this restricted domain. So here again, here's the sine graph in black along with the hot pink sine to the negative 1 or the inverse sine graph, okay, that's not restricted. So that's what it looked like. It would look like literally a flip about this y equals x line. But we are going to work with the restricted domain for our questions that we're going to be doing. So up at the top here, you'll see that there's a number of different ways you can express the inverse graph. Sine to the negative 1 of x is one way you could say it. Also, arc sine is very common. Arc sine x. Inverse sine x written like this is also common, and ASN, arc sine x, abbreviated like this. So you might see any one of these for online or in your textbook. All right, so again, we want to focus on just the portion of the inverse function because it's actually a function, okay? In this case, it's actually a function. If we go any further up here, it doubles back over itself. It wouldn't be a function. So the domain, negative 1 to 1. The range, negative pi over 2 to positive pi over 2. Okay. So that's just an explanation here. Okay, here's some examples as well of how we can work this. And you remember this from math classes previous. If you wanted to solve for an angle, like this would be a question that you would have seen before in Pre-Cal 30. And how do you do that? Well, you take the inverse sine of both sides, and this is what you actually do, right? So when you see this, you say, hey, I know what that means. It's just another way to write this statement. So we're looking for an actual angle that gives us a sine of this. That's what this means. What's the inverse of root 3 over 2? Well, the angle that yields us a sine of value of root 3 over 2, that angle is pi over 3. You can do that in your calculator, or you can look on the unit circle. Okay? So what angle gives us this value? Well, root 3 over 2 is up here, right? This is 1/2 comma root 3 over 2. That's this point, and it's associated with 60 degrees or pi over 3 radians. All right, here's the sine value. That's what we're looking for. Another one here, sine to the negative 1. Okay, we got to make sure that this is in the domain of the function. So really, it's actually that negative pi over 2 to positive pi over 2. So I know that looks like we wrote that down as the range here. Okay, but that means that for the original function, that is the domain. Okay. So yeah, so these values have to be between negative pi over 2 and pi over 2, yeah. Okay, so here's another thing that we learned, and there's going to be some questions in the next video that we're going to work with this. But a property of inverses is that when you multiply or you take the inverse of a function, then you can yield back this value. So in the case of the sine function, the inverse sine of x is x. The inverse cos of x is x. And the inverse tan of x is x. And so really, if you see this situation, as long as x is within the proper domain, and that's going to be, you're going to check this one as between negative pi over 2 and pi over 2, then these just cancel out, and you're left with whatever this value is. That's what you're left with. Okay, they undo each other. All right, and here we did some examples where we see that. Okay, pi over 4 is within this domain here, accepted domain, and so I can just cancel these out. And so it's pi over 4. Here, negative 1/2 is in here, so those cancel each other out. Negative 1/2 is your answer. This is the only one that's a little bit strange because this 7 pi over 6 is not in this domain. So what we have to do is we have to solve this individually first, separately. So the sine of 7 pi over 6 is, you look on your unit circle, you go to 7 pi over 6, you look at the second coordinate, it's negative 1/2. Now can we do this? Yeah, we sure can. That means the sine of what angle gives us negative 1/2? And there your answer is pi over 6. So you see how it's important that we didn't just do this because this is not the correct answer. So you have to make sure that it's within these bounds here, first of all. Okay, this is an example I did in class, but I also, I'm doing some examples in my next video of this exact thing right here. What happens if you mix your trig functions, and that will be in the next video you can watch. But that is just the basic rundown of what an inverse trig function is, a little description of where the domain and range is, and we're only considering a certain domain so that it is a function. These are the different variables, and again, here's your graphical representation, right? Your graphical representation of what an inverse is, reflected about that. Okay? There's 7.5.